Alright, I just wanted to make a quick video for a little bit of the Hawks help, just to kind of go over the problems that you're going to see. If it says solve it using elimination, the Gaussian-Jordan elimination, guys, it's not going to know whether you use elimination or substitution the old-fashioned way or the way that we just did. So if you want to do substitution like we just did, you can. So, for example, we'll do number 2. Let's say we use, let's say we use, um, let's do elimination. So I'm going to multiply this one by 9, this one by 2. I'm going to add them together. You get x equals 1. If you look at the solution, guys, it's already x equals 1. So then you can plug it back into an equation and solve for y. Again, the computer's not going to know which way you use. I'm okay if you guys do this as long as you know how to solve it. So you know it's one solution, 1, 3. And you can do that for all of these. So if it says use Gaussian elimination, you can just use regular one. Or row operations, don't forget, if you're multiplying a row, the first one stays the same. So I'm going to write row 2. It's going to stay the same. Now I'm going to multiply it by -7 and add it to row 1. So this is going to become a 0. This becomes 56, and this becomes 59. And that would be your final answer. So that's what they're after. So just make sure you know your row operations. If you do have one that's going to be infinitely many solutions, here's how you write this. And I should have went over this in 10.1. I tried to explain it in the instructions, but just so you can get some extra help on it. You're going to solve one of them for x. So like take the first equation, for example. So you get infinite solutions after you solved it. So now solve one of them for x. So I'm going to subtract 5y and divide by 2. So I get -5 halves y minus 2. What you're going to do is you're going to take that answer and put it in for the x coordinate in your coordinate pair. And you're going to do comma. This is going to stay y. This is always going to be y. That's how you can enter it every single time. It doesn't matter which equation I solve. I'm still going to get the same thing. -5 halves y minus 2. That's what you're going to put in. So that's just an infinite solution one. Construct the augmented matrix. Guys, this is where you're going to put the x, y, and then z. All right, so for example, this one, my x is 4/5. My z is -1/2. I would subtract the 9/2 over, so it's -9/2. You just got to make sure you watch your signs. I would subtract the 3/5 over, so it's -3/5. All right, and then you're going to get 1, -2, -8, 7, but I need to subtract the 1 over, so this is going to become a -3. And lastly, just not right in the right order, so you got to rearrange it. 6, 7, -3, -6. So make sure it goes x, y, z in your columns equals a number for all the equations, and then fill out your augmented matrix. Row operations, again, you're just going to do both the row operations it says to do. Notice row 2 is what you're multiplying both of them, so row 2 is going to stay the same no matter what. So the first one you're going to do is you're going to multiply by -8, add to row 1, multiply by -3 and add to row 3, and then you're going to get your answer, which is down here. But notice row 2 is the one that stays the same because that's the one you're multiplying by. The order, guys, rows by column, so this is a 2 by 3. 2, 1, so I'm going to go to row 2, column 1, you're going to get 3. I'm going to go to row 1, column 2, get 10. All right, we went over that. Augmented matrix. This one you switch row 1, switch row 2. And that's pretty much it, guys. If you have any questions over this, please let me know and I will help you. Again, when it says solve the system, you can just use good old-fashioned substitution elimination. You don't have to use the Gauss-Jordan method. I did make you practice it on the homework just so you got the idea of it. If you have any questions, please let me know. Send me an email. I know it's a quick video, but just to help you a little bit.